Good evening, everyone. I'm Tejashani. Come back for LLM assignments. So we discuss project 5, that is CBOW, that is continuous bag of words. So before you go to project, we discuss what is CBOW. Okay. So yeah, it is a word representation. It's using and simple thing here. Input is like given. Given is context and output is word. That's it. That simple thing you have to remember. Okay. That is given is context, output is word. That's it. You can learn what is entropy, what is cross entropy, forward and backward bias, each and everything which we can see in program. Okay, let's go that. I already changed the CD and just you can simply run it, and yeah, you can see all is in right. So you don't flicker, you don't you don't think about all what is what. I will explain in detail. So yeah, wait a second. Lot of output, and this is all for terminal. And yeah, here vocabulary is unique tokens is 30, vocabulary size is 30, encoding training tokens is 59. So here we considered first 20 vocabularies, like first 20 words I take here. So this is, and this is the neighbor count here. Okay. This is simple thing. Before we can see all such kind of thing. That's why I don't prolong this. So infinity difference grand check. This is important because of in this we can see infinity difference. Whatever we see, all this happened for before. Like this is count and infinity different gradient check is very mandatory because of assignment in second task is infinity difference. So graduate check and report the maximum relative error. Okay, that's why you can see what is happening here. Okay, and initial loss is this, and context, like here W context means word context. Word can context max relative error is this one, and W word max relative error is this one. Overall maximum is 1.34 is enough, and gradual check is passed, and okay, you can see, right? So you can see all what is happening. You don't think all what is what. Okay, yeah. Here is the vocabulary. What is vocabulary? And you can see, and related what is the rate for learning rate experiment. You can see before, and this is the window size. What is the experiment for Windows, and window size is different, and and further like learning state and rows, final loss, total loss, everything, like what is the software max time, everything is changed, everything is different. Why it's different? Because of your window size is different. Okay, so like that we can say all such kind of things. And here CPW is count is context is this 55 comma 4, target vector is 55. So for the training CW training we can see all these things. Here train the model, whatever we can see all the training model. And here see we can all the values, right? You can see now in graphs. Okay, yeah, now we can see what is here loss. This is the matrix. Wait, this is the graph for loss training. Okay, here training loss entropy and how much it's lost, and this is understood values, and this is the thing. And another thing is timing. Timing is also very important. So softmax time, what is softmax time, and what is the total enrolled time? This is the difference between both. Okay. Next we can talk the nearest neighbors. That is very important for each and every context, right? So here I take human for this all neighbors, and it's the values whatever you get. And for mission, and likewise computer, likewise system, likewise user, likewise time, likewise learning. So now we can see this is all the terminals. We can see all the values. Now we can see the representative. Okay. So you can see the context here. Okay. whatever context you can see, we can see all this context, whatever happened, whatever enabling things, all these things. Okay. Now, window experiment. That is d is equals to 1. Examples, how many examples you can generate? 57. Okay. So this is the training model for this variable training. Size is this. And learning rate is 0.01. So increment the value is all. And branch size is 130. This is important. Branch size is 130 and training size is 57. Because of you can generate the 57, right? So you can see in graphical way. Wait a second. Yeah, this is for that. This is for cross loss. See, what are the difference between this one and this one? Window size is different. Understand? Window and IR change is different. That is the thing. Here, window size is 1. Okay? I think you get it, right? So, likewise, timing also. Timing also. Here you can see. Okay? Timing is also different. Like, how can you see the timing difference? Here, I take from 1, from 1, 2, 3, 4, like. But in Windows, I can take only numerical values because you can even values because of the frequency starting from like this. I think you get it, right? So that's the happening. And I'm sorry, I forgot to tell you, this is a little bit of, I think it's take 10 minutes. So hold on and just be concentrate what I'm trying to say. If you have anything, if you get any doubts, just let me know in description. I will explain you further. Okay. Likewise, I for again neighbors, all this like human, mission, system, all. Okay. Now I'm go to d value is 2 and our generator is 55. Okay. For that size is window size is 2. I will told you rate is 0.05. 100% embedding is there because it's NLP. HS size is 3, batch size is 128 and training size. You can see all this in terminal. You can see in, yes, exactly. You can see in graphical way. Here you can understand window size is 2, IR size is 0.05. This is the part. Okay, likewise, you can see in timing part also. This is the thing. In that, we can see 0.00002. Here, 0.0005. That is the gradual change between the values. If D is 1, one value, D is 0 is one value, D is 2, there's a gradual change. Why this gradual change happens? Because of for this you can remove unwanted like duplicates, repeated values, or any unwanted things like helping verbs, non verbal words, all such kind of words are removed by the decreasing d. Okay, I think you get it now. Yeah, likewise, I'm taken another d5. This is all examples why I'm taking such kind of examples because of you can understand how much variance for each and every single number. Like d is 0, one value, d is 1 in one output, d is 2 is one output, d is 5 is one output, right? So why you are taking such kind of inputs? Why? Because of then you can understand how much variance it is, how it's able to change the efficiency of it, right? So that's why I take such kind of all. And window size is 5, rating is 0.05, Pro size is 13, batch size is 128, training size is 49, like example generated 49. So this is the theory, and yeah, we go to graphical representation. Wait a second. Yeah, here you can see window size is 5. This one is this, and the values also change gradually. And these you can do timing also. Here we also take for timing window 5. Yeah, window 5. This is the part. Okay. So now we can see whole comparison table. Before you can go to graph, just have a look for comparison table. Then you can get. And again, you can change IR values also. Okay. Learning rate values also you can change. You can change, and obviously values are changed. See here, I take 0.05 values, and different values are different, right? Likewise, see, how can I say that? Yeah, timing part. You can see timing part. Wait, I will mark. Yeah, we can see timing part here. This is 0.0 seconds, actually zero. No, it won't take much time for 0.05. Likewise, 0.1, it take some time. Likewise, you can see each and everything in properly. Okay. And completely here, we can see pure numpy, what will happen. Full softmax is where entropy, cross entropy is also passed, and mini batch is also passed. Training loss curves is also passed. Learning part like 0.05, 0.1, like all such kind of is also done. Learning all LRs, like LR means learning late experiments, and nearest neighbor search, in the sense values we change now. What the values we change here? Yes, obviously timing change is also change. All such kind of is also there happen. So finally we can see comparison table here. Here we take only all biggest values. Yes, you can see here. I'll take D1, D2, and D5, right? So comparison table we discuss about. Here you can see D1 is equals to 1, D2 is equals to 2, D2 is equals to 5, and the representation. Okay, then you can understand what is the variance of each and everything. If D1, D2 is near numerical values, that's why they're getting small difference. But D2 and D5 are a lot of difference because of in between two decimal values is there. So that's why there's a gradual change. Then you can understand if D is changed, what's the output we get it, right? I hope you understand what I'm trying to say. So this is all about CPUW, whatever like training part, learning rate, and timing, loss, entropy, all such kind of things that happen here. And thank you. This is problem 5.